Rocket Lab is hitting a pretty special milestone with its Electron rocket, reaching launch number 50. It's reaching that milestone with the launch of 5 satellites for French Internet of Things company Kinéis on a mission called No Time Toulouse.
If you look back through history, it's really rarefied air for a rocket to hit 50 launches. Within commercially launched rockets, and even government, developed rockets, there's a lot that never get sort of past 10 or 20. And so if you actually plot out all the rockets that have launched 50 times, there's not that many.
With this milestone upon us, we thought now was a good time to pause, take a look at Rocket Lab as a company, how it got to this point, and why they believe that the rocket in Rocket Lab doesn't quite fully capture the entire picture. Rocket Lab got its start back in 2006, beginning as a suborbital launch company with its Atea rocket. Its first successful launch was on November 20th, 2009. That made Rocket Lab the first private company in the Southern Hemisphere to reach space. The company continued earning its stripes through ventures like a viscous liquid monopropellant demonstration for the Defense Advanced Research Projects Agency, or DARPA, in 2010. The following year, Rocket Lab, along with defense contractor L2 Aerospace, debuted Instant Eyes. It's a device described as a handheld rocket-launched drone. And then, a launch demonstration in 2012 of the VLM for DARPA. But in the middle of the 2010s was a key point for the company. The first hot-fire test of a Rutherford engine happened in 2013, and in 2014, Rocket Lab formally announced its Electron rocket to the world. The two-stage launch vehicle stands at 18 meters or 59 feet tall, and it has a diameter of 1.2 meters or 3.9 feet. Fully fueled, it weighs about 13,000 kilograms or nearly 29,000 pounds and has an advertised launch cost of less than $5 million per mission. The carbon composite rocket features 9 Rutherford engines on the first stage and a vacuum Rutherford on the second stage. Both stages use a combination of liquid oxygen and rocket-grade kerosene to deliver up to 300 kilograms or 661 pounds to low Earth orbit. Originally, Rocket Lab advertised the debut launch as coming in 2015, but it didn't ultimately debut until 2017 with the launch of a mission called This is a Test. However, that mission failed to reach orbit as planned. Electron would go on to successfully reach orbit and deploy customer payloads on its second launch. That was a rideshare mission called Still Testing. Speaking with Spaceflight Now, Rocket Lab CEO Peter Beck described the financial challenges of bringing a small rocket to market.
Although the capital requirements for a small rocket is far less, which makes it far more achievable to build something, especially starting from zero, a little rocket is so much harder to build than a big rocket. Honestly, it's just so much harder. Every gram is accounted for. You make trades on, I want to put triple redundant sensors here, but I can't afford the mass. So how else can I assure reliability of the system? Whereas a big rocket, throw 3 pressure transducers, it equates to 0.00000% of the total rocket's mass and move on. So, I can honestly say with my hand on my heart that building and operating a small rocket is just vastly more difficult than a larger rocket.
And financially getting to launch was no small task either. Unlike billionaires Elon Musk and Jeff Bezos, who can pump their own personal wealth into their launch companies, SpaceX and Blue Origin, Beck needed to raise millions of dollars through multiple rounds of seed funding. In 2021, Rocket Lab became a publicly traded company through a special purpose acquisition company or SPAC merger. It now trades on the Nasdaq Stock Exchange under RKLB. It's something that Beck says creates more accountability.
The discipline of being a public company certainly helps. You cannot be wasteful in any sense.
Since those first pair of missions, Electron launched 47 more times. Rocket Lab also increased their pad availability from 1 on the Mahia Peninsula of New Zealand to now 3, 2 in New Zealand and 1 on Wallops Island, Virginia. Beck says part of their success to this point was putting a lot of engineering work into the vehicle prior to getting off the ground that first time back in 2017.
If I look at the very first Electron that we launched and number 50, and I put them side by side down on the factory floor and ask you to come in and point out all the things that were different, you would struggle. And that's kind of part of the success of why Electron has been successful, is we didn't bring to market a minimum viable product that needed a whole bunch of work after we put it put our first one in orbit.
He noted that there have been block upgrades and tweaks along the way, but the vehicle has largely remained the same. Part of getting the rocket to where it is today, though, was going through some mission failures. To date, there have been 3 missions with customer payloads on board that were not able to deliver them to orbit.
I prefer not to think about it because they're such devastating moments. They're incredibly painful, and yes, it's true that after those moments you build a better vehicle. But I always remind the team to never be happy, because if you're happy, the rocket gods will come down with a baseball bat and let you know who's in charge. So we're always striving to improve the vehicle. Every opportunity we can to improve it or make it more reliable, we take. And it's just the harsh reality of spaceflight is it's incredibly difficult.
Liftoff.
With the 50th Electron rocket mission called No Time Toulouse, Beck and the team are not only celebrating hitting that round number, but also the pace at which they reached it.
Out of all the commercially developed rockets in the world, Electron reaching 50, we did it in the fastest amount of time. So we scaled faster to 50 than anybody else, faster than the Falcon 9, faster than Pegasus, faster than anything else, commercially. And that's a really hard thing to do, because whether it's a giant rocket or a little rocket, the scaling element is the same, and it's super, super hard.
Beck says their success was built on the early launches. He says Rocket Lab took its time to establish a confidence in the launch marketplace, and says that helped convince those like the National Reconnaissance Office and the U.S. Space Force, along with several companies, to begin ordering their own launch contracts.
I would say it takes you a dozen launches, to build the trust with the customer base that you're going to deliver them successfully and their service is going to be good. So I think it takes that amount of time and that execution to ultimately win the customers, and that's why it's incredibly hard for any new rocket company to bring a new product to market, especially if there's already a product in the market that is doing well. The barriers to the entry just become extraordinarily high.
In order to continue competing in that marketplace, Rocket Lab has been turning their attention to reusability. They made some strides in recent years, like recovering the first stage booster from the water multiple times, and during the August 24th, 2023 launch called We Love the Nightlife.
2, 1, and liftoff.
They launched a booster with a flight-proven engine for the first time. When speaking with Spaceflight Now before the 50th launch, Beck said that the reusability of Electron, though, isn't their prime focus right now, but rather the focus is on their forthcoming Neutron rocket.
The Electron reusability program has been absolutely fundamental in our ability to develop Neutron. I would hate to walk into a reusability program building a big rocket, having zero experience with re-entering a rocket into the atmosphere. That would be very scary. But we've spent a lot of time perfecting that with Electron, and there is no boost back burn for Electron. There is no deceleration burn through the atmosphere. We just bring that thing in raging hot through the atmosphere and control it all the way down and deploy a parachute, splash it down in the ocean. And where we've got to with that right now is the tank looks like new.
Beck says much of the composite technology and the approaches will be, quote, directly transferable to Neutron. So far, teams have completed a full-scale carbon composite tank and placed the Archimedes engine on the test stand to begin its testing campaign. 9 of these will power Neutron's first stage, producing about 1.5 million pounds of thrust at liftoff. Beck affirmed that mid-2025 is now the plan for debuting the 43-meter-tall rocket. He says they're feeling comfortable pushing it beyond the previous plans of a first launch in 2024.
Everybody underestimates how hard it is to put something into production, especially a rocket. And putting something in production is not just, workers on a shop floor repeating a task. It's all of the material flow, the work instructions, supply chain, and all that kind of infrastructure. So we've invested, very heavily over many years to build all that infrastructure. So when a new product comes online, it kind of slots into the grooves of the railway lines and away we go.
As Rocket Lab looks to the next 50 Electron rocket launches and beyond and bringing Neutron online, they're also continuing to focus on building out the business as a fully end-to-end space company, as Beck puts it.
Well, in hindsight, I should have never called it Rocket Lab because, the intention was never to stop at rockets. 2/3 of the business is actually spacecraft and spacecraft components. And we have over 40 spacecraft ranging from, missions going to Mars through to, communications constellations and national security missions on the books right now. If you ask me, what do I think the space industry looks like in 5 or 10 years' time, I think it'll be largely dominated by a few companies that have the capability to build whatever satellite they want to build, launch whatever satellite they want to launch, and then operate it. And I think, probably the best example of that right now commercially is Starlink. I mean, nobody can compete with Starlink from a commercial communications platform because, Starlink can build their own satellite and launch it on demand. And I think that is the model that will proliferate going forward.
And Rocket Lab plans to keep Electron firmly in the game to help do just that. Reporting for Spaceflight Now, I'm Will Robinson Smith.